part 2 of the story, I suppose. So let's see what actually happens in practice. It would be easy to be fooled by these results, because at a glance it looks like Gary's got the 2-to-1 result he wanted, 1.98 or whatever, even though the 2-to-1 ratio didn't work out for the both balls at once. You'll see why in a minute. This is an illusion. Like all results that Gary gets that seem to support him, they're just an illusion of one sort or another. In this case, I'll explain why in a second. I'll show you how the full mass slows right down. It goes about 2/3 of the way in half of its number of frame counts. But that doesn't happen with the half ball. That behaves pretty much as you'd expect. So it's the full ball that's at a disadvantage, not the half ball. So no wonder the ratio came out at 1.98 to 1. The one that Gary wants to say is at a disadvantage in the previous old experiment, where he got the 1.7 result he wanted. A quick reminder of that. I should have realised something was wrong with this experiment when the 2-to-1 ratio we expected from both balls launched together came out at 2.08 to 1. Not quite right. And as for the balls launched singly, they should have come out at a ratio of 1.4 to 1. It actually came out at 1.7 to 1. Gary argues it should have come out at 2 to 1, and that the reason it didn't was because of the skidding. Now let's do the same thing for the half ball. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. After 10 clicks, it's gone roughly halfway, just over halfway, which is pretty much what you would expect. That reflection of the edge of the ball in the mirror is really distracting. It makes it hard to see the edge of the ball. Why did I use a mirror? Because I was a bit stuck for a piece of glass that would fit in the gap. So you can see the half mass travelled the expected distance in the first 10 frames, roughly half of the number of frames. So it's the full mass which is at a disadvantage, not the half mass when skidding. Touching the speeds up. Incidentally, I suppose my twin air tracks are just another kind of skidding, really. Don't take too much notice of those numbers because they don't actually start at the very beginning of the travel. They're only as a visual guide for me, really. They won't pan out if you do the math. They aren't even aligned perfectly between the two tracks, about 2 millimeters out or something, because this was early days just making the air track. Oh, it rolled. Okay. I'll give it 3 goes. 1, 2, 3. 1, 2, 3. So now you've seen the experiment, you can appreciate that making the half mass skid gave it a distinct advantage, not a disadvantage. It goes about 4 times further and faster. That's the released back edge, and it's only moved the back edge of the blue ball that much, but it's moved the red ball much further, hasn't it? 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39. Okay, so it's 39 clicks for this full ball to travel the full distance. So if we halve that, call it 20. Let's see how far it's gone after 20. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So in 20 clicks, it's gone roughly to the red line. So we can see it's travelled about twice the distance in 20 frames than it did in the next 19 frames. In other words, it's slowing down massively, isn't it? 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 8, 39.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20.
So no wonder the ratio came out at 1.98 to 1. Now let's do the same thing for the half ball. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. After 10 clicks, it's gone roughly halfway, just over halfway, which is pretty much what you would expect. So you can see the half mass travelled the expected distance in the first 10 frames, roughly half of the number of frames. So it's the full mass which is at a disadvantage, not the half mass when skidding. Another one which at first glance appears to support Gary, but 2, 3, 1, 2, 3, 1, 2, 3. Just a rough count. Yeah, don't expect the numbers I'm about to count to match up with what's written on this page, because that was done at 240 frames a second, whereas I'm just now counting at 60 frames a second, I think it is. Go number 1, both balls together. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. That was 21 really, wasn't it? Go number 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Go number 1 of the full mass. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 maybe. Go number 2. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. I think I missed one off at the beginning actually, so I think it is 16. Go number 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 I suppose. 15 and a half, 16. Go number 1 of the half ball. 1, 2, 3, 4, 5, 6, 7, 8, 9. Go number 2 of the half ball. 1, 2, 3, 4, 5, 6, 7, 8. Go number 3 of the half ball. 1, 2, 3, 4, 5, 6, 7, 8. And that concludes the voting of the United Kingdom jury. Here's a very rare instance of Gary appearing to be right, obviously being wrong, because I've juxtaposed it with another experiment where he's obviously wrong. He's by his own standards, he's wrong. I thought it might make it more interesting, though, than just watching me frame counting an experiment that proves him right. If he wants to see himself appearing to be right, then he's going to have to suffer watching another experiment where he definitely is wrong.
This
decides the question once and for all.
I've made the band stronger now, so it's got more power. One distance, 8 centimeters. Another distance, 8 centimeters. Go 1, 2. The only part you're actually interested in looking at is this part here. Let's just focus on the bit we're actually interested in. Turn it around the right way and make it fill the screen. 3, 1, 2, 3, 1, 2, 3. Okay, gonna frame count this one. Frame counting the lever first. Why am I frame counting the lever, you might ask? Well, I'm not 100% sure about this, but my thinking is the velocity of the lever must surely be more representative of the launch velocity of the actual balls before they've had a chance to lose speed. But we've got a problem, haven't we, there? Because on the one hand, the balls are decelerating once they've been launched, but the lever itself is accelerating. So the frame counting I'm doing isn't an accurate representation of the velocity in either case, really, is it? It's just the best we can do. We don't have a way of instantaneously measuring. We can only measure over a period of time, and the lever is accelerating and the balls are decelerating. So I would defer to the opinions of people like John Walker, or an actual theoretical physicist like Draftscience. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, I think. Yeah, 16. I'm going to flash the documentation up after every single frame count so you can see where I've recorded the numbers and you can easily go back and check. So 1, 2, 3, 4, 5, 6, watching 7, me 8, frame 9, counting 10, 11, 12, is going to drive you as batty as it's driven me. 20, so I've got a plan. 22. I'm going to say 22 and a half. I've tried very hard to make it as painless as possible to watch this boring process of me frame counting, pressing the button 240 times just to advance 1 second's worth of footage. So I'm also going to show you a more useful video.
This experiment decides the question once and for all.
I'll put the audio of 1 in the left ear.
Here's where they're saying it would land. 1.4.
Yes.
So instead of 2x, it'll only go 1.4x.
Yes.
And the audio of the other one in the right ear.
This experiment decides the question once and for all.
It did prove things once and for all. Therefore, this experiment below is utterly meaningless. Even if the pool ball experiment does sometimes appear to prove Gary right, it's obviously wrong. There's obviously something else going on. So if you don't like listening to both at the same time, you can turn one or the other down. Now, after every count, I'll show you a quick picture of the table where I keep a list of all the numbers. But this particular example appears to support Gary's case. Other ones don't. So, we've got to suck it up, haven't we? Same as Gary's going to have to when he's proved wrong. 24, 25, 26, 27, 28, 29, 30, 31,
Just
32,
take
33,
any kind
34,
of
35,
spring-loading
36,
device.
38, 39, 40.
I used
41,
your
42,
idea.
43, 44,
62 grams.
45,
1, 2, 3,
44 and a
4,
half then,
5,
okay, so
6. 62 grams.
Actually, that looks a bit
The large
sloped
ball
that way,
hit
so I'm
there.
going to stick to
44.2.
45.
8 out of 8.
A small one, that's 31 grams.
1, 2,
62.1.
3,
8 out of 8.
I'd say 4.5.
2.1 divided by 44.2 equals 1.4, 1.4.
It doesn't land here, and instead lands here.
Which is what happened.
But here's where they're saying it would land. 1.4.
Yes.
So instead of 2x, it will only
23
go
and a half, let's
1.4.
say.
Yes.
This can't be the truth. This bullshit.
You are calling nature bullshit.
Can't possibly be the truth.
I don't think Gary will ever get it. This is a dead theory, Gary. Half the mass does not go 2 times further, 2 times faster. It goes 1.4 times. I don't think Gary will ever get it.
You still don't get it, Gary.
This experiment decides the question once and for all. Decides the question once and for all. Once and for all. Shot him off the edge of a table. 1 in and see how far it goes. Put 2 in, see how far it goes. This decides the question once and for all.
22, 22 and a half.
The large ball hit there.
44.2.
9, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41,
Nice clear
42,
mark.
43, 44,
The large ball hit there.
44.2.
40, should I say 46,
Exactly the same place.
46. So I think we need to do some calculations
Exactly.
there. So for the
Exactly the
full ball,
same
that's
every time.
137, half ball, 68.5.
same.
So 1, 3,
8 out of 8.
A small one there, that's 31 grams.
exactly 2 to 1 ratio.
62.1.
So the other counts ought to be valid. Let's see then.
Remember, Gary says, this is decisive. Once and for all, he says it. Once and for all.
11.
This experiment decides the question once and for all.
I'm not
Exactly
sure
the
if that's
same
left
place.
the lever.
62.1.
10.5.
Again, they're all landing in the same place. 62.1.
62.1 divided by 44.2 equals 1.405.
This experiment decides the question once and for all.
Exactly in the same place. It's one mark on top of another mark.
5,
Again.
26.
That's it. This was the experiment that Gary said was the decider. Would confirm things one way or the other, once and for all.
And Gary was right. It did prove things once and for all. Therefore, this experiment below is utterly meaningless. It's just another one of my failed experiments. We know this because Gary's own experiment proposal proved beyond any shadow of doubt that you cannot make half a mass go twice the speed. It will only go 1.4 at best. Denying this just makes Gary look very, very stupid. 11, yeah, 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. Go number 1, half ball. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9, that's so wrong, it's ridiculous. I'll keep it in and don't want to be accused of cherry picking. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. I'm erring in Gary's favour a little bit here. This could be 13 and a half, but I don't want to push it. Go number 2. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That's a bit more like it, but it should be about 14 really, shouldn't it? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Probably 14 really wants it, but give him the benefit of the doubt. Okay, go number 3, half ball. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10. Wow. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Again, probably 13 and a half really if I'm being fair, because the bar is kind of sloped this way, isn't it? Call it 13 though, so there's no accusations of bias against Gary. 13. Okay, it is what it is. To be absolutely honest, I'm bored shitless of it, so I don't really care either way anymore. Okay, this will continue to a part 3, I suppose. Maybe some dual air tracks, something a little bit more interesting, hopefully. 2.